Okay, hello. Good morning to everyone who are joining us today. Okay, welcome again to all school students, to teachers, to all parents from all around Malaysia, and not forgetting in Sabah itself, and to all UMS students and to all UMS staff who are present to this session today. Thank you again. We meet for this session with our new speaker today. With our new speaker today, Dr. Sylvester Mantihal from the Faculty of Food Science and Nutrition in University Malaysia Sabah. Welcome, Doctor. Okay, for an introduction, for those who have joined us for the first time, okay, we would like to introduce this STEM speaker series is actually a co-joint effort with today with the Faculty of Food Science and Nutrition, University Malaysia Sabah, okay, which are aimed to deliver unique and interesting STEM topics, STEM as in science, technology, engineering, and mathematics. So these topics are actually designed by our subject matter experts from each of the faculties to increase the interest of school students, of teachers, and also for the community alike to venture into the fields of STEM. So for today's session, please be informed if you have any questions from audiences today. Please feel free for you to drop your question into the chat box at the right side of the YouTube live session today. And we will read it out for our speaker today for him to comment on the questions here. Okay, so for today's session, we will be providing e-certificate to all participants, okay, which will be given to school students and also UMS students and also everyone who are present. But you all must fill in the form, and we will share with you a QR code which will be shared at the end of the program today. So please stay tuned with us until the end of the program, yeah? Okay. So on a brief introduction for our speaker today, with us is a very distinguished academician from Faculty of Food Science and Nutrition, Dr. Sylvester. Okay, for a brief introduction, Dr. Sylvester is a lecturer and an enthusiast researcher at the Faculty of Food Science and Nutrition in UMS. And his interest is actually in food product development using 3D food printing technology. So we know this food printing technology is very new to us, especially in Malaysia. So this is very relevant for our topic today. And he is also involved in 3D printing related to a seminar and exhibition. He's also involved as an exhibitor in academic seminars, and he is used to be representing the University of Queensland in Australia, yeah, as a 3D food printing demonstrator to educate and also to spread the awareness of the novel technology and broadcasted in Channel 10 in Australia. Okay, in Australia, not in Malaysia. So he has also received his PhD in 2019 from the University of Queensland, Australia. And currently his work is involved in investigation of local consumer perception of 3D printing technology, and he has published several journal articles of in related to 3D food printing, and he was also a member of the Australian Institute Food Science and Technology, also known as AIFST. So without further ado, and we do not want to waste time, we please welcome Dr. Sylvester with his topic today, 3D food printing, food for future. Doctor, please be invited, Doctor.
All right, thank you very much for the kind introduction. Hello, everyone. So again, my name is Sylvester. So today I will be sharing a bit of my experience about the topics, which is 3D food printing. So bear in mind, I just want to share the presentation first. Okay. Now, hello everyone again. So welcome to the STEM speaker series number 8. So today's I have been approached to provide an insight about what it is actually about 3D food printing. So I'm from the Faculty of Food Science and Nutrition, Faculty Sains Makanan dan Pemakanan, UMS. Okay, so throughout the session, so please feel free to drop a question in the live chat session in the YouTube. So, and I will entertain the questions at the end of the presentation. So, is that okay? So before we start our presentation today, so I would like to ask the audience about this specific topic. So have you heard about 3D food printing before? Okay, so please comments in the live chat. So if you have heard or maybe have encountered with, or if you have an experience with, hopefully. Okay, so please type in the chat box if you have heard about it, or if you have heard about it, dari mana? Okay, so where is the sources? From social media, from YouTube, from the internet. Okay, so the outline for today's session is mainly about what is 3D food printing, the introduction, material for 3D food printing, okay, 3D printing technology that is available now, currently available in the market, types of printable material, current status and prospect of this technology, and also we'll discuss about the conclusion. Now, so what is 3D food printing action? So if you have heard about 3D printing, it is similar process to this one, okay? So 3D printing is a process of creating an object, or in our case here is food, in layer by layer motion. So starting from the bottom layer and building up to a height of the layer. Okay, so it's depend on the food design. So starting from the bottom, okay, so why we start printing from the bottom, not from the top? So because we need to make a first layer of foundation first for the subsequent layer to attach to it, and then much more stable when it being printed layer by layer. So back in 2007, which is approximately 10 years ago. Okay, the first stage of printing, food printing development, building and creating shape were the main concern, because at that time, printer just came in. So technically, the printer just came out, but there is no research has been done if it is can be applicable to food. So last time, creating and also building shapes. Okay, so what shape can we make? For example, like in the photo that I've shared on the bottom. Okay, chocolate, pizza. Okay, so creating shape was the issue. So what can we make through 3D printing? And then the parameter issues, such as how big is the nozzle that we need, what is the temperature, and also how fast the printing has to be moved. Okay, so but now currently we are moving towards food personalization. So what is food personalization is? So food personalization is something that we personalize to what we actually need and also want. For example, Like I want the food to be high in protein and also has a heart shape. So that's what it means by personalization. So each and every one of us has our own needs and preferences. So perhaps with this technology, we can do that. Okay. So two major components that are really vital for that to be feasible, which number one is modifying recipe. Okay, so we have a lot, millions of recipe out there that we can acquire from internet, online, or from our own family. Okay, so there's a lot of recipe. So how can we use this recipe and can modify this recipe so that it is compatible to food printing and also creating textures. So I will discuss how we can create more about textures throughout the presentation. Okay. Now, so the types of material for 3D food printing. So as you can see here, there is a variety. So this is not for the three materials not for food. So this basically material that being used for 3D printing in the industry, which is metallic materials such as steel, polymer materials such as ABS and also nylon, ceramic such as alumina and also zirconia. But today we are focusing on this one, food. So we look into several material that is printable, such as sugar, okay, the white sugar that we have at home, chocolate, uh, fruits, vegetables, snacks, gels, and recently, a good friend of mine have just finished her project about meat printing. So as you guys can see in the photo next to it, which is fresh meat printed from this technology. Okay, so how does 3D food printing works? So technically, it has to undergo several process, but it is not that really difficult to manage. So first thing first, how do we need to achieve the design that we want? Of course, we have to design, right? So we're using 3D design software to do so. So I believe there is a lot of software available now online and also software that we can download through our smartphone. Okay, so we can use that. So we can use that to design the specific design that we want. And then we extract the file into the G-code generator, which is the G-code. This G-code generator is also available that come with the printer itself. And after that, after we generate the G-code, and then we can download it to the 3D food printing, and voila, that's the 3D printing object. So I got a lot of these questions about 3D food printing. Is it really hard to design? Susah sangat kamu design 3D printing. Sudah mau design, and then we have to modify recipe. Actually, it is quite easy. Okay. So it is very easy to design food. Why? Because nowadays we are so lucky that there's a lot of softwares available online, which is free. So later, after this session finished, so perhaps audience can look into this specific website, tinkercad.com. Okay, it is free, so you guys can sign in. But I think if you guys are underage, you guys need to have the consent from your parents. Okay, so that's it. It's free, so you guys don't have to download this kind of software. So what does this design do or this software do? is you basically can design anything that you want. Okay, so it is online, so you guys don't have to download it. So it does come with its own tutorial. So how to make certain shapes and how to make holes inside the shape, how to merge shapes, how to combine shape. So this particular website has its own tutorial. So perhaps if you are really interested into designing food using this software, or perhaps your schoolwork, I do suggest this one. Okay, so look up tinkercad.com. So it's very easy. It is self-explanatory, so you don't have to worry about whether you need to have like high skill in designing food or in design particularly. So using this as a basic tool for the design is very helpful. Now, while I'm sharing, so now I'm playing video of 3D printing. So the first video that is in motion now is a meat printing. Okay, so this is probably one of my best projects so far. Okay, so we are printing meat using 3D food printer, extrusion method. So now the printer is actually printing the second layer. So if you guys look closely, so it make a round shape. Okay, it is quite interesting technology actually. So based on what we have designed, okay, so this design is a round shape, a cylinder. So this printer actually can read the file instantly and then produces the shapes. And of course, with a meat product, we have to modify certain of the recipe so that it is easier for this printer to print. So this is the close up for the printing. So if you guys can see there, so like I mentioned before, it is layer by layer technique. So this layer depending on the design that we design. Okay. Now we move to the second video. Okay, so this is the chocolate printing. Okay, so this is edible chocolate. So once you printed it, so you can eat straight away. So this shape is hexagon shape with cross infill to make the chocolate more stable. Okay, and then the third video is broccoli, vegetables. So technically, we can print anything out of this technology. So isn't that fascinating? So if you have any questions so far, please feel free to type in the chat live chat box on the right hand side of you. Okay. So so all of these three material, only one of it is natively printable. Natively printable means you can print it straight away without modification of the recipe, right? So if you guys can guess which one of the material that is natively printable, maksud natively printable is yang kita boleh print terus dan tidak memerlukan apa-apa modifikasi ataupun bahan tambahan untuk print. So if you guys can guess which of this material, meat, chocolate, or broccoli, is natively printable, so you guys can put in the chat box, on the right hand side of your screen. So the host will notify me later. Okay, so siapa yang dapat jawaban dengan betul so far? Okay, so parties that is really active in 3D food printing. So back in 2007, so the first university that really deal with this technology is the Cornell University. Okay, they developed their own 3D food printer, which is called Fab Home. So Fab Home uses a powder as the material. And then fast forward to now, up until 2015, okay? So we started it back in Australia. But I just want to highlight what actually triggers the researchers to do more study about 3D food printing, which is, as you guys can see, in 2013 there, NASA has involved also in this project, particularly on bringing food to the space. So they thinking of like, how do we want to bring food in the space without carrying so much supply? So they actually invested into one of the university. So they have studied about this 3D printing, and that's where it's all started. So basically, NASA are really interested into taking this technology to the space. Okay, sangat menarik. Now, 3D printing technology. So we have four printing technology. Okay, so the first one is using laser, selective laser sintering. The second one we use hot air. The third one we use liquid binding, and then the fourth is extrusion method. So out of these four, mainly we are focusing now on extrusion method because this is more suitable to paste and also semi-solid food. The other three technology requires the food to undergo several process, and the food need to transform into powder form. Okay, so we will look into the extrusion method today. So two types of extrusion method there is available now in the market. The first one is automated piston, and the second one is using rotary motor. Okay, so automated piston, just imagine how we use a syringe. Okay, jarum itu kan. So we put the material in, and then it pushes the material out from the nozzle. In the syringe, we use needle, right? So, but for in this case, we are using nozzle. So we push that. However, the pressure will be automated by the printer itself. Similar to the rotary motor, we are using a motor to spin up the material, and it's extruded using the rotary extruder. So if you can closely see the inside of the rotary extruder, it looks like a screw, right? So the food material will travel in a screw-like motion, so it's spinning, and then it will be extruded through the nozzle. Okay, so both of these methods use temperature. Okay, so this is the food printer that's really available now in the markets. So the first one, the yellow one, okay, I call it the legend because this is the first ever printer that has been produced in Australia at that time. Okay, 2015. So he has been with me for the past 4 years. Okay, so 3D food printer, the first one, made of China. It's called Kunshan Orimi 3D chocolate printer. Okay, it's semi-auto. You need to do it manually. Okay, and then B, okay, much more advanced. Looks like a bit robotic style. It's called the Sheen Tech Shinove extruder. So as compared to the Orimi, this one has dual extruder. So you can actually use two types of material and print at once. So this means first layer can be meat, the second layer can be vegetables, right? So and then alternately, so we can make a burger patty out of that. So we can mix vegetables and also meat at the same time. The third one is the chocolate age creator. So this is basically just for chocolate. from the UK. This is fully automated. Okay, so it comes with a touch screen, so much more advanced as well. Now, so this is a few of the printing that I've done so far. So this is a chocolate. This is edible chocolate. Okay, so different shapes. So personalization, like I've said before, kalau saya mau the shape to be Mickey Mouse, I can do that. How do I create Mickey Mouse? I can design Mickey Mouse from the software. So if you want to do it dinosaur shapes or triangle shapes, pyramid shapes, you can. And this technology will make it feasible for you. Okay, so now this is some of the output of the object or the food that has been printed worldwide by various company and by research group. Okay, the first one is 3D printed carrot, various printed pasta shapes that Gorilla also collaborated with, 3D printed chocolates, okay, and then yeah, we have also pizza, okay, a burger with the shoe shapes dough, okay, making pizza, right? So everything is possible. So back to this one, the type of printable food material. So I hope that the audience did type in before. So out of the 3 video, which one is the native printable, right? So if you guess it chocolate, yes, it is. It is correct. So chocolate is natively printable, which means you don't have to modify the state of the chocolate, the recipe of the chocolate to be able to print. Okay, but we can't print the cocoa powder. It has to be chocolate, which means chocolate that we bought from the supermarket, the chocolate block that we bought from the supermarket. Why chocolate block? Because it has a stable crystal inside it that allow the chocolate melt and also solidify back to the temperature. Okay. Also, cheese is natively printable because cheese can melt and also solidify room temperature and also gel. However, non-printable material, which is meat, okay, daging, any kind of meat, is not printable. Potato, vegetables, and fruits. Some also rice as well. So this is non-native printable. So how do we want to make this printable? So I have, for example, I have rice at home. I want to make it a Barbie shape, for example, right? So how I can make this happen? So to enable to do so, adding something what is called like hydrocolloid is the best way. Hydrocolloid is what we call it a stabilizer, okay? So that the object can retain its shape after its printing. And also we look into alternative ingredients. So alternative ingredient can be various. It is from algae, fungi, seaweed now, much more common, lipin, and quite uncommon to human, insects, serangga. Okay, so insects are the noble source of protein and fiber. So this has been done in the study from the Severin et al. 2018. So in that research, they found that insects has really high source of protein. Okay, so in the project they call it bisect operating. The insect powder mixed with extrudable icing and also soft cheese were used as a printing material to shape food structures and make it tasty pieces. Okay, so if you guys ever wonder like what you eat, right? So if you do this manually, right? So if you want to make it more interesting, like I said, interesting shapes. Okay, So if you want to encourage people to eat, right? So the eye eat first, isn't it? Kan, mata makan dulu. So when we look something that really interesting, it triggers us want to try that, right? And but before, without knowing what is the ingredient, isn't it? So this technology can help you to do so. But however, this insect is edible. Okay. So this is the things that we need to consider the most when we want to design food. The rheological properties. What is rheological properties? It's actually mainly the viscosity. How viscous is the material? And then the chemical properties. Okay, chemical properties of food will change. Okay, um, such as the gelation. Okay, wettability. How does the moisture affect the food or the temperature, for example? Okay, and also the structural and mechanical properties. So the focus of the structural and mechanical properties of food is how stable is the object. So bila kita print, right? So can we hold the, for example, chocolate like this, or it is so rapuh, okay? So when you touch it, it's collapsed. So how does that affect the printing? So this is the thing that we need to consider in the 3D food printing research in order to come out with interesting and very innovative food product. Okay. Now, also a lot of questions out there why we need to print food when the food is readily available in the market, right? So we can just grab from the shelf from the market. Food is available, so we don't need to do another extra process to do so. So the first one, so why do we print food? So customized food design. So it is allow us to design various food shapes and also flavors. So imagine, okay, so at home, especially like now, right? So in pandemic, we want to do something for our special one, birthday, or to celebrate something. So we want to come up with something that really memorable. Okay, so this technology can help you to do that. So how? For example, we can create a birthday cake hopping out of this uh, technology without requires any skills of molding, shaping. Okay, and it allows us to be more freedom in food customizations, design, colors, flavor for home users. Okay, so especially for adventurous people out there, especially like you guys, still young and you guys want to explore more and want to experiment more. This is the technology that really suitable for you, so you guys can explore and to be more creative and to be more innovative. And also textures modification. So textures modifications maybe to us is not a problem because we can eat properly, right? We can eat solid food properly. We don't have to make our food soft in order for us to consume our daily meal, right? But there is people nowadays that experiencing dysphagia. Dysphagia means they cannot swallow hard food. Dia tidak boleh telan makanan yang solid, makanan keras. So it has to be in soft food. So with this technology, we can customize the design and we can customize the textures as well, so that they can actually eat something that look like chicken, but it is soft for them to swallow. Okay. Now this is actually a chocolate. Okay, so in a various shapes and design that mold cannot do. Okay, so for example, like if you guys can see the chocolate with the honeycomb internal structures in there. So there's no mold can do that, right? Or the maze inside that, okay, and then the star, okay, and then the spiral. So this technology allows us to do so, okay? So we can create many things. Although it's a basic shapes, but we can also do something really interesting in the inside of the object with this technology. Next one, why we need to print food. We can actually personalize nutrition. So remember I shared about textures modification, okay? So we can actually personalize nutrition like that. So this project is by the TNO Netherlands, okay? So back in old folks home where these old people cannot swallow hard food, okay? So they have to make everything in puree, mashed potato, pureed chicken, okay? So they mix, so it's kind of like boring to eat, right? So if you eat the same thing every day, right? It's not like the same thing, but the textures of it make you feel motivated to eat too, right? So when you look the the appearance of the food, like I don't want to eat that, right? So because it is puree. But with this technology, we can make it more interesting. We can print, um, for example, like this one, 3D soft chicken. Okay, it does look like chicken, but it is soft. So they can actually scoop it out and then eat it, and then they can swallow it easily. Okay, so food printing enables precise control people diet as well. So with the modification of recipe. Yeah, so this is the examples of the project uh, in the nursing home in Germany that they did. Uh, so printing carrot, chicken leg, mashed potatoes, and mushrooms. So they make the plate looks more interesting. Okay, then and it's trigger them to eat more, right? And then why we need to print? Because we can incorporate alternative ingredients. So like I mentioned previously, insects, right? So it is not the insects that we print like one piece by piece. So we need to also to transform these insects into printable form, such as the powder, and then we need to make the powder mixed with other ingredients as well to make it more palatable. Okay. And also modifications of traditional recipe. For example, if we have our own family recipe that probably it is too hard to make. Okay, so it does need to be shaped up to mold. Okay, so with this technology, we can do that, right? So we just need to figure out what is the portion of each of the recipe, and then we are good to go. Okay, so the future prospect for this technology for individual user, non-complex machine, creative design, and personalized nutrition. So the printer that's available now in the market, especially 3D printer, it is more user-friendly now, individual user-friendly. It does come with a high technology because now we are moving towards industrial 4.0, right? So which means that it has to be technology enabled. Okay, so we can control now the machine just using our smartphone. Okay, and then for the small scale food production, we can do artistic design. We have our own bakery. Okay, so we can do custom design for our customer if they want this kind of design that's really intricate, right? Intricate mean designing complex. It is take time to mold that and then put that into pieces. However, with this technology, 3D printing, we can do it easily. Okay, and then industrial scale for production. So it needs to be economies of scales, which means you need to produce mass production, produce banyak, right? How we can do this? So perhaps the machine has to be embedded with multiple nozzles, okay, in order for them to produce food at once, right? Now, way to increase consumer awareness of 3D food printing. So I believe that nowadays it is not the printing that is challenging, okay? To find out the material or to study about what material that is suitable for printing is quite feasible or boleh dibuat pada masa ini. Tetapi um, consumer awareness, pelanggan, okay? So pengguna. So you at home, are you willing to use this technology as part of your food production at home, right? So it is still new in Malaysia now that it is still new. It is not been widely spread yet about 3D food printing. 3D printing per se, it is common worldwide, but not food printing. So perhaps to increase the awareness now we have social media. So social media is everything nowadays, right? So each of us has our own social media. We scroll our social medias every day. So information can be disseminated through the social media so that people are aware the existence about this technology. Okay, and then also reportable sources of information, and as well as the actual display of 3D printed food. Interestingly, there is no, this is just my case from um, Australia. So there is no exhibition so far yet. Last time about 3D food printing. So what I did was I bring all the machine that I have from the lab, bring them out. So like the photo that I shared to you, okay? So bring it out and then I print there and then people can see it. So when they see it, they really fascinated by it and then they are willing to try. Okay. So and then so this way we can create more awareness about the technology. Actually, this technology is really, really safe, right? It is a food grade. It is that we need to ensure that the process of it are safe. That's it. Okay. So to end my session today, this technology is a powerful tool to create personalized food by depositing nutrients into food. It is also promising, but consumer may need to be educated. Similar, last year we did a mini research among people in Klang Valley in KL, okay, about their awareness about 3D food printing, okay. Their attitude changes, okay. Sikap mereka berubah apabila diperkenalkan dengan technology ini. It slightly changes, but it is not significant. So that's mean that we need to work more in order to make the public aware about this, because this is quite an interesting and promising technology. Okay, so consumer need to be educated about this possibility to counteract with the perception that food processed to this degree may not be particularly nutritious. So with that, I end my session. Thank you very much. So now I open for the Q&A session for the audience to ask any questions.
Thank you very much for the interesting and very informative topic here, Doctor. And
Okay.
it's also very relevant for the future of food technology in Malaysia as well. Thank you again for the talk, Doctor. And then we will bring up a few questions from the audience today. So basically, the first question we have is from maybe Miss Gan Siong Pei, MOE. So the question is, can the food be consumed immediately? So that is the first question, Doctor.
Okay, thank you so much, Ms. Gan. There is a yes and no to the question. So if it is so every food that we bring is edible, but however, for example, like chocolate, we can immediately consume it. But like for vegetables and also for meat, for instance, we need to undergo one more process, which is cooking process, before we can consume them.
All right, thank you very much for the very brief and direct answer, yeah, Doctor. Okay, we move on to the second question, Doctor, from Widen 70121. Okay, how about the cost and especially for stall seller? So maybe he's referring to the ones we are selling for the stall sellers lah, Doctor.
Okay, so perhaps the question is the cost of the 3D printer. I'm assuming the cost of the 3D printer. Okay, so last time the cost of the 3D printers is very expensive, right? It can cost about $10,000. But now the cost is reduced up to 1,000. You can get the printer with $1,000, which is kalau dollar referring to dollar. That's about 4,000 to 5,000 ringgit. You can get a one with very high tech 3D printer already. Okay, so it is different from the manufacturer in the sense that more advanced 3D printer, so quite costly, but it is worth for the investment because we want to get printer that is really user friendly. So you guys don't have to do it manually, put everything manually. We just need a printer that is like, we put the ingredient in, few click away, then it is ready to go.
Thank you very much, Doctor. Okay, we hope that will answer their question, yeah, Doctor. Okay, we will bring up again another a question from Izati Atira. Okay, a question is, hi, Doctor. Is that 3D food printing will make any kind of effect towards eating if we eat the food?
Okay. Hi, Izati. Good question. So, any effect, I'm assuming it is health effect, right? So, it does not have any health effect to us, except if we are allergic to it. So, you need to know, okay, so we need to know that what food that we can consume and what not. For example, if you are allergic to nuts and some of the flour, right? So perhaps you don't want to bring that as well. So also, if you are heavily allergic, let's say, so do not make sure that after we print food, we need to really wash that the food system, okay, the food printing system, so that it does not have any trace of the allergens, right? So I'm assuming we don't have any problems so far that have read throughout the project that undergone 3D printing before. They don't have so far a problem for health benefit. Plus, we can also enhance the nutrition out of this technology. It's just that we need to be careful with what allergens that we have.
Thank you. Thank you very much, Doctor. So maybe they will need to focus more on what they are allergic towards, yeah, Doctor? As usual for food allergens lah. Thank you again, Doctor. And then we can move on to maybe this is the last question from the audience today. Okay, from Widen 7012 again. So he's asking, perlu packaging lain untuk cover makanan lah. So that's the question lah, Doctor. Do we need another cover?
Okay, good question, Vidya. Perlu ada packaging. We do not need to have packaging for the food that we produce. Okay, if we use it for household use mean kita di rumah we print, and then perhaps if we have to masak the food, then we just consume it directly. However, if we are talking about commercial, okay, so we do need extra packaging for that as well. So we can't sell to consumer directly the food alone, right? So we need to be in packaging. So it does have required packaging in that sense, but if household use, we don't need to have any packaging.
All right, thank you very much, Doctor. I think that is the last of the question from our audience today. Thank you for all of everyone's participation for our session, yeah, for the questions from our audience, and also not forgetting our very enthusiastic lecturer and also speaker today. Thank you again, Doctor.
Thank you
So
so much.
yes, thank you again, Doctor. So we hope everyone have enjoyed our the presentation and the session today by our wonderful speaker. And we will share with everyone the QR code link for the link of attendance today. And also we will be giving all the attendance link in the web chat, the YouTube chat. So please stay with us. So for the session today, it is a pleasure to have all of you today, and especially our speaker for the session today. Thank you again, Doctor. So with this, we will conclude this webinar today. And thank you again, and see you in the next webinar series, STEM speaker series. Thank you, Doctor, and thank you, everyone.
Thank you so much.
Thank you, Doctor.